Let's take a look at example 2. In this example, we have a rational equation, meaning there's x's in the bottom. So we want to remember when it comes to the rational equations that we should check our answer, but in particular, we need to make sure that whatever we get does not make the denominator equal to 0. So no matter what in our end, we can't let x equal 2 or negative 2, meaning if we do get 2 or negative 2, we got to throw those answers out. Now, in order to solve a rational equation, we say, hey, that sure looks like a fraction to me. Fractions suck. Get rid of the fractions. So we multiply both sides of the equation by x plus 2, x minus 2. Now remember that means put that x plus 2, x minus 2 into the top of each fraction. So just in the numerator. We're not trying to build up to a common denominator. We're trying to get rid of our denominator. And so we do that by putting stuff into the top that's going to divide out with the stuff that's in the bottom. So we're multiplying both sides of the equation by x plus 2, x minus 2. And we can see that x minus 2's divide out in the first fraction. X plus 2's divide out in the second fraction. So now in our first fraction, we can go ahead and just distribute the 5 across to get 5x plus 10. And in the second fraction, we can distribute the 4 to get 4x minus 8. And on the right-hand side, that's a difference of squares, and we have x squared minus 4. We can now combine like terms on the left. And we're going to move everything to one side because we do not have a perfect square equals a number. So we're going to subtract the 9x to the other side and subtract the 2 to the other side. So now we have a quadratic that's equal to 0. We should try to factor. If we're not able to factor, then we have to use the quadratic formula. Now we're not able to factor. There's nothing that multiplies to be negative 6 and adds to be negative 9. So we do have to use the quadratic formula. Notice that our middle coefficient is odd. And so the trick does not apply. We just got to plug it in with 1, negative 9, and negative 6. So we're going to get the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. So as we simplify up here, we get 81 plus 24 underneath the radical. 81 plus 24 is 105. I don't believe there's any perfect squares that divide evenly into 105, so this is as good as we can get. Now as I'm looking at this, I'm supposed to plug my answer back in, I'm supposed to check it, but I'm really checking to make sure it doesn't equal 2 or negative 2. Neither of these answers are 2 nor negative 2, and so these are my two answers. Now remember, when entering this in our homework system, you enter this as two separate answers to say there's the plus version and there's the minus version.